Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in field of piping for last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about plastic materials. There are several plastic materials. Some of these are PVC or polyvinyl chloride, UPVC or unplasticized polyvinyl chloride, PE or polyethylene, LDPE or low-density polyethylene, LLDPE or linear low-density polyethylene, HDPE or high-density polyethylene, PAGES or polypropylene, ABS or acrylonitropbutadiene styrene, PVDF or polyvinylidene fluoride. PVC or polyvinyl chloride is a synthetic resin made from the polymerization of vinyl chloride. It is second only to polyethylene among the plastics in production and consumption. PVC is used in an enormous range of domestic and industrial products, from raincoats and shower curtains to window frames and indoor plumbing. The lightweight, rigid plastic in its pure form. It is also manufactured in a flexible plasticized form. Unlike other thermoplastics, which are entirely derived from oil, PVC is manufactured from two starting materials. 57% of molecular weight of chlorine derived from common salt. 43% is derived from hydrocarbon feedstocks. Ethylene from sugar crops is also being used for PVC production as alternative to ethylene from oil or natural gas. Vinyl chloride is also known as chloroethylene. It is most often obtained by reacting ethylene with oxygen and hydrogen chloride over a copper catalyst. It is a toxic and carcinogenic gas that is handled under special protective procedures. PVC is made by subjecting vinyl chloride to highly reactive compounds known as free radical initiators. Under the action of the initiators, the double bond in the vinyl chloride monomer's single unit molecules is opened, and one of the resultant single bonds is used to link together thousands of vinyl chloride monomers to form the repeating units of polymers which form large or multiple unit molecules. Pure PVC finds application in the construction trades, where its rigidity, strength, and flame resistance are useful in pipes, conduits, siding, window frames, and door frames. It is also blow molded into clear, transparent bottles. Because of its rigidity, it must be extruded or molded below 100 degrees centigrade, the temperature high enough to initiate chemical decomposition, in particular, the emission of hydrogen chloride HCl. Decomposition can be reduced by the addition of stabilizers, which are mainly compounds of metals such as cadmium, zinc, tin, or lead. In order to arrive at a product that remains flexible, especially at low temperatures, most PVC is heated and mixed with plasticizers, which are sometimes added in concentrations as high as 50%. The most commonly used plasticizer is the compound di-2-ethylhexylphthalate or DHP. It is also known as diethylphthalate or DOP. Plasticized PVC is familiar to consumers as pipes, floor tile, garden hose, imitation leather upholstery, and shower curtains. Very fine particles of PVC can be dispersed in plasticizer in excess of the amount used to make plasticized PVC, which is 50% or more, and this suspension can be heated until the polymer particles dissolve. The resultant fluid, called a plastisol, will remain liquid even after cooling but will solidify into a gel upon reheating. Plastisols can be made into products by being spread on fabric or cast into molds. Flexible lugs can be made by dipping the hand-shaped form into plastisol, and hollow objects such as overshows, can be made by casting plastisol into a mold, pouring off the excess, and solidifying the material remaining on the walls of the mold. PVC has been an occasional object of controversy since a link between vinyl chloride monomer and cancer was established in 1973. Environmentalists and health advocates raised concerns over the possible ill effects of exposure to substances such as residual vinyl chloride monomer, hydrogen chloride, or unknown metallic stabilizers, and phthalate plasticizers. Industry officials maintain that these substances are scrupulously controlled and are released from PVC in trace amounts that have not been proved harmful. Physical properties. Tensile strength is 2.60 newtons per square millimeter. Notched impact strength is 2.0 to 45 kilojoules per square meter. Thermal coefficient of expansion is 80 into 10 raised to minus 6. Maximum continuous use temperature is 60 degrees centigrade. Density is 1.38 grams per cubic centimeter. Resistance to chemicals. With dilute acid it is very good. With dilute alkalis it is very good. With oils and greases it is good or variable. With aliphatic hydrocarbons it is very good. With aromatic hydrocarbons it is poor. With halogenated hydrocarbons it is moderate variable. With some alcohols it is good. UPVC or unplasticized polyvinyl chloride. UPVC has excellent chemical resistance across its operating temperature range, with broad band of operating pressures. It has lower amount of plasticizers. Due to its long-term strength characteristics, high stiffness and cost-effectiveness, UPVC systems account for a large proportion of plastic piping installations. UPVC is resistant to many acids, bases, salts, paraffin hydrocarbons, halogens, and alcohols. It is not resistant to solvents, aromatics, and some fluorinated hydrocarbons. Pay or polyethylene has been successfully used for the safe conveyance of potable and wastewater, hazardous waste, and compressed gases for many years. LDPE or low-density polyethylene and LDPE or linear low-density polyethylene are the first of the polyolefins. Low-density polyethylene or LDPE was originally prepared some 50 years ago by the high-pressure polymerization of ethylene. Its comparatively low density arises from the presence of a small amount of branching in the chain of about 2% of the carbon atoms. This gives a more open structure. Low-density polyethylene or LDPE is the most useful and widely used plastic, especially in dispensing bottles or wash bottles. It is translucent to opaque, robust enough to be virtually unbreakable and at the same time quite flexible. Chemically, LDPE is unreactive at room temperature, although it is slowly attacked by strong oxidizing agents and some solvents will cause softening or swelling. It may be used at temperatures up to 95 degrees Celsius for short periods and at 80 degrees Celsius continuously. LDPE is ideally suited for a wide range of molded laboratory apparatus including wash bottles, pipette washing equipment, general-purpose tubing, bags, and small tanks. Properties of LDPE and LLDPE. It is semi-rigid, translucent, very tough, weatherproof, good chemical resistance, low water absorption, easily processed by most methods, low cost. Physical properties of LDPE and LLDPE. Tensile strength is in the range of 0.20 to 0.40 newtons per square millimeter. Notched impact strength is 0.0 kilojoules per square meter. Thermal coefficient of expansion is in the range of 100 to 220 into 10 to the power of minus 6. Maximum continuous use is up to a temperature of 65 degrees centigrade. Density is in the range of 0.917 to 0.930 grams per cubic centimeter. Resistance to chemicals. With dilute acid it is very good. With dilute alkalis it is very good. With oils and greases it is moderate variable. With aliphatic hydrocarbons it is poor. With aromatic hydrocarbons it is poor. With halogenated hydrocarbons it is poor. With alcohol it is very good. HDPE or high-density polyethylene is flexible, translucent or waxy, weatherproof, has good low-temperature toughness to minus 60 degrees centigrade. It is easy to process by most methods. It is low cost and has good chemical resistance. A linear polymer, high-density polyethylene or HDPE is prepared from ethylene by a catalytic process. The absence of branching results in a more closely packed structure with a higher density and somewhat higher chemical resistance than LDPE. HDPE is also somewhat harder and more opaque, and it can withstand rather higher temperatures, so 120 degrees Celsius for short periods. It can't withstand 110 degrees Celsius continuously. It lends itself particularly well to blow molding, for bottles, cutting boards, duping baskets, dippers, trays and containers. Physical properties of HDPE or high-density polyethylene are: tensile strength varies from 0.20 to 0.40 newtons per square millimeter. Notched impact strength is no break kilojoules per square meter. Thermal coefficient of expansion varies from 100 to 220 into 10 raised to minus 6. Maximum continuous use to temperature is 65 degrees centigrade. Density varies from 0.944 to 0.965 grams per cubic centimeter. Resistance to chemicals. With dilute acid it is very good. With dilute alkalis it is very good. With oils and greases it is moderate variable. With aliphatic hydrocarbons it is poor. With aromatic hydrocarbons it is poor. With halogenated hydrocarbons it is poor. With alcohol it is very good. Pages or polypropylene is suitable for use with foodstuffs, potable and ultra-pure waters, as well as within the pharmaceutical and chemical industries. Polypropylene is a plastic polymer with the chemical formula N times C3H6. It is used in many different settings, both in industry and in consumer goods, and it can be used both as a structural plastic and as a fiber. This plastic is often used for food containers, particularly those that need to be dishwasher safe. The melting point of polypropylene is very high compared to many other plastics, at 160 degrees centigrade, which means that the hot water used when washing dishes will not cause dishware made from this plastic to warp. This contrasts with polyethylene, another popular plastic for containers, which has a much lower melting point. Polypropylene is also very easy to add dyes to, and it is often used as a fiber in carpeting that needs to be rugged and durable, such as that for use around swimming pools or on miniature golf courses. Unlike nylon, which is also often used as a fiber for rugged carpeting, it doesn't soak up water, making it ideal for uses where it will be constantly subject to moisture. The properties of polypropylene include: it is semi-rigid, it is translucent, it has good chemical resistance, it is tough, it has good fatigue resistance, it has integral hinge properties, it has good heat resistance. ABS or acrylonitropbutadiene styrene is used for the conveyance of potable water, slurries, and chemicals. Most commonly used for DWV or drain waste vent applications. ABS is an ideal material wherever superlative surface quality, color fastness, and luster are required. ABS is a two-phase polymer blend. A continuous phase of styrene acrylonitropylipolymer sand gives the material rigidity, hardness, and heat resistance. The toughness of ABS is the result of submicroscopically fine polybutadiene rubber particles uniformly distributed in the sand matrix. ABS standard grades have been developed specifically to meet the requirements of major customers. ABS is readily modified both by the addition of additives and by variation of the ratio of the three monomers acrylonitro, butadiene, and styrene. Hence grades available include high and medium impact, high heat resistance, and electroplateable. Fiber reinforcement can be incorporated to increase stiffness and dimensional stability. ABS is readily blended or alloyed with other polymers, further increasing the range of properties available. Fire retardant may be obtained either by the inclusion of fire retardant additives or by blending with PVC. The natural material is an opaque ivory color and is readily colored with pigments or dyes. Transparent grades are also available. A variety of grades are available for different applications. The material is typically injection molded or extruded. Physical properties are: tensile strength is in range of 40 to 50 megapascals. Notched impact strength is in range of 10 to 20 kilojoules per square meter. Thermal coefficient of expansion in range of 70 to 90 into 10 raised to -6. Maximum continuous use temperature is in range of 80 to 95 degrees centigrade. Density is in range of 1.0 to 1.05 grams per cubic centimeter. Resistance to chemicals. For the root acid it is very good. For the root alkalis it is very good. For oils and greases it is very good. For aliphatic hydrocarbons it is moderate. For aromatic hydrocarbons it is poor. For halogenated hydrocarbons it is poor. For alcohol it is poor but varies. PVDF or polyvinyl fluoride has excellent chemical resistance, which means that it is widely used in the chemical industry as a piping system for aggressive liquids. It is a synthetic resin produced by the polymerization of vinylidene fluoride or CH2CF2. It is a tough plastic that is resistant to flame, electricity, and not attacked by most chemicals. PVDF is injection molded into bottles for the chemical industry and extruded as a film for electrical insulation. Its flame resistance makes it especially desirable for insulating wire in buildings and aircraft. PVDF is also piezoelectric, changing its electrical charge in response to pressure and, conversely, exerting pressure in response to an applied electric field. This unique property makes it a good material for transducers in devices such as headphones, microphones, and sonic detectors. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.